In this session, we're going to solve equations with rational expressions. Let's just dive right in. Solve 1 over 5x minus 1 over 4x plus 1 over 3x is equal to negative 17 over 60. I'll show you two techniques that I've seen for solving an equation like this, and then thereafter we'll just kind of stick with one of them. But both techniques start out with finding the least common denominator of the fractions. And if you consider 5x, 4x, 3x, and 60, the denominators that we're looking at, then hopefully you will agree that the least common denominator is 60x. The first technique involves multiplying both sides of the equation by the least common denominator. And let me rewrite the equation here. Okay, so I've rewritten the equation. What I've done is I've left room to multiply each term by the LCD 60x. The reason I don't want to just put parentheses around one side or the other and multiply both sides by 60x that way is because each of these terms, when I multiply, is going to, the denominator is going to divide out, leaving a different factor in each case. What I mean is, for the first term, we have 60x multiplied by 1 over 5x. Well, the 5x will divide into the 60x, leaving 12. And so, for the first term, after we've reduced, we end up with just a 12. In the second term, when we divide 4x into 60x, we're left with 15. And that was a negative term, so I'm going to write down minus 15. And you see when the 4 divides into the 60, it leaves us 15. Earlier, when the 5 divided into the 60, it left us with 12. And if I don't write down the 60 more than once, I run the risk of over-reducing, essentially. So just to be safe, I'd like for you to do what I'm doing. And when we divide 3x into 60x for the third term's denominator, we end up with 20. And finally, on the right-hand side, the 60 divides into the 60x, leaving x. And so on the right-hand side, I have negative 17x. We'll simplify what's on the left-hand side. Looks to me like that's going to be 17 is equal to negative 17x. And then divided by negative 17 will give us that x is equal to negative 1. The other technique involves getting common denominators all the way across, and then essentially clearing the denominators once you've done that. So let me show you what that looks like. So I've again rewritten the equation, and what I'm going to do in this case is multiply each term by whatever factor is missing to get the LCD. It's the same least common denominator, of course. It's the same problem. And for the first term, we have 1 over 5x. I want the denominator to be the least common denominator, which means I'm missing a factor of 12. And of course, since we're dealing with fractions, we have to multiply numerator and denominator. Remember, fractions are like children. How come he gets a 12? I want a 12. You know, you've got to affect both of the numerator and denominator in the same way. For the second term, we have a 4x, and it looks to me like we need to supplement that with 15 over 15. For the third term, we have 1 over 3x, which we should multiply by 20 over 20. And then finally, on the right-hand side, we have that negative 17 over 60, and it's simply missing a factor of x, so we multiply by x over x. Now what I've done is I've achieved common denominators, which was what we were after in this technique. Let me rewrite all of the terms reflecting that common denominator. And after multiplying, I have 12 over 60x minus 15 over 60x plus 20 over 60x is equal to negative 17 over 60x. And it seems to me that at this point we could get rid of the fractions by multiplying the whole thing, both sides, by the least common denominator. Well, in this case, the denominator is going to divide out of every term, right? Because now all the denominators match. There are no leftover pieces, or leftover factors to be technical. And the equation that I'm left with here is 12 minus 15 plus 20 is equal to negative 17x. And if that's looking familiar, it's because it is. It's exactly the equation that we just ended up with. For that reason, I'm going to stick with the first technique for the remainder of this video. Let me go ahead and circle that x is equal to negative 1, because that is indeed the answer to the first example. And for that next example, we're looking at solve 10 over x minus 12 over x minus 3 plus 4 is equal to 0. As before, we need a least common denominator. It's tempting to say that since you see x as part of x minus 3, that x must be a common factor, and it's not. Case in point, if x were to equal 5, then x minus 3 would equal 2, and there's no common factor there. So x is a term of x minus 3, x is not a factor of x minus 3. Punchline there being that the least common denominator for x and x minus 3 is x times x minus 3. As before, I'm going to rewrite the equation with space to throw in the least common denominator for each term, and then multiply by that LCD. And so here we have x times x minus 3 times the factor of 10 over x minus x times x minus 3 times 12 over x minus 3 plus 4 times x minus 3. And then on the right hand side, I know it's 0, but it's just good form. We are multiplying both sides. It's not going to change that it's 0, but like I said, good form. Dividing out the factors that will divide out in each term is going to leave me with 10 times x minus 3 for the first term, 12 times negative x, if you like, for the second term, so minus 12x. And then we have the 4x times the quantity of x minus 3 is equal to 0. So it looks to me like we need to clear the parentheses where they exist, so I'm going to distribute, after which I end up with 10x minus 30 minus 12x plus 4x squared minus 12x is equal to 0. I want to collect like terms. So I have 4x squared, let's see, 10x minus 24x. It's going to be negative 14x, I believe, minus 30 is equal to 0. At this point, what we have is a quadratic equation. I notice that the coefficients of all the terms are even, so I'm going to divide each term by 2, giving me 2x squared minus 7x minus 15 is equal to 0. And now I need to factor this quadratic. So I know this is going to factor into a pair of binomials. 2x squared for the first term indicates that the first term in each set of parentheses, or respectively, should be 2x and then x. And then I need factors of 15 that'll mingle with this 2x squared in such a way that we end up with negative 7x for the middle term. I'm thinking 10 and 3. Where'd that come from? Okay, quick review. 2x squared, the coefficient is 2. We have negative 15 as the last coefficient, or the constant. That multiplies to be negative 30. I now need factors of negative 30 that will add up to negative 7. And it seems to me that negative 10 and the positive 3 multiply to be negative 30. They add to be negative 7. So what I need to do is pair this 2x in the first set of parentheses with something that will give me a negative 10. In other words, that 15 is going to be broken up into negative 5 and a positive 3. We can check our OI, like, FOIL, OI in the middle. Checking our OI means we're looking at 2x times negative 5 is negative 10x. 3 times x is positive 3x. Those add up to be negative 7x. That matches the middle term that we were looking at, so I know that our factoring is correct. Using the principle of zero products, or the zero product property, or as a lot of people might just say, solve the thing, we can split up 2x minus 3 is equal to 0, or x minus 5 is equal to 0, giving us x is equal to negative 3 halves, or 5. At this point, we need to go back to the original equation, because we had, I don't know if you noticed, variables in denominators. What we need to make sure is that we do not end up zeroing out a denominator. And so whether you do it at the beginning or the end, it doesn't really matter to me, but I'd like to make a little note here to myself. I'm going to call it note. X cannot equal 0 and x cannot equal 3. If x is 0 or if x is 3, then one or the other of the denominators is going to zero out. Scrolling back down, looking at our answers, we had negative 3 halves and 5. Neither of those is 0 or 3, and so I'm confident saying that those two are the solutions to this equation. Next, we're going to solve 1 over x minus 1 minus 1 over x plus 1 is equal to 2 over x squared minus 1. Again, the name of the game is find the least common denominator. In order to do so, I need to factor the denominator on the right-hand side. X squared minus 1 factors into x plus 1 times x minus 1. So that is, given the other two denominators, going to be the least common denominator. In keeping with what we've done, I'm going to rewrite this with room for the least common denominator for all the terms. And so for the first term, we have x plus 1 times x minus 1 times 1 over x minus 1. Then we have minus x plus 1 times x minus 1 times 1 over x plus 1. And on the right-hand side, since we have 2 over x squared minus 1, which is the least common denominator, I'm just going to multiply the right-hand side by x squared minus 1. In each term, we have something that's going to divide out. So in the first term, we're left with, if you'd like, 1 times x plus 1. I don't usually do that, but if it was a number other than 1, I would have written it. So I just wanted you to see it clearly. Second term, x plus 1 divides out, so I end up with negative, again, if you want 1, but I wouldn't really write that usually, times x minus 1 is equal to, and on the right-hand side, the x squared minus 1 divides out completely, leaving me with simply 2. I'm going to clear the parentheses where they exist, which means for the second term I'm going to distribute the negative 1. We end up with x plus 1 minus x plus 1 is equal to 2. It's a little weird. So x minus x goes away. I have 1 plus 1 is equal to 2. Well, duh. We went through all that for that. As you may recall, if you solve an equation, the variable drops out, you end up with a true statement, the answer is going to end up being all real numbers. I know, it feels kind of cheap, doesn't it? Let's move on. 5 over x minus 4 minus 3 over x minus 2 is equal to x squared minus x minus 2 over x squared minus 6x plus 8. As before, we're going to factor the denominator that we can factor, and lo and behold, it factors into x minus 4 times x minus 2, which happens to be the product of the other two denominators. And so, once again, what we have is the least common denominator. In keeping with what we've done, I'm going to rewrite this, and then hit all of the terms with the least common denominator. So in the first term, the x minus 4's divide out. I have 5 times the quantity of x minus 2. In the second term, the x minus 2's divide out. I have negative 3 times the quantity of x minus 4. And on the right-hand side, that denominator was the least common denominator, so the whole thing divides out. I'm left with x squared minus x minus 2. Something that I've kind of blown past in a couple of these examples is that in the second term here, we have negative 3 times the quantity of x minus 4. And what that means is we're going to distribute a negative number. That's going to be characteristic when we have a binomial and a term that has a minus in front of it. So I just throw that in there to make you aware that you need to pay attention to the signs, particularly when you're distributing. Well, distributing throughout here is going to give us 5x minus 10 after we distribute in the first term, then minus 3x plus 12, and on the right hand side we're going to say that that's equal to, it didn't change, x squared minus x minus 2. What I have here is a quadratic, as indicated by the x squared term. And so what I'd like to do is get everything on the same side so that I can factor. What that means to us is on the left-hand side, we're going to collect like terms. 5x minus 3x. It's going to give me 2x. Negative 10 plus 12 is going to give me plus 2. And on the right-hand side, we have x squared minus x minus 2. Bringing everything to the same side will leave us with x squared minus 3x minus 4 is equal to 0. X squared minus 3x minus 4 factors into x minus 4 times x plus 1. Since that equals 0, we can say that either x minus 4 is equal to 0 or x plus 1 is equal to 0, leading us to conclude that x is either equal to 4 or negative 1. Or is it? If we scroll back up and consider the note that we made last time, we can make the same kind of note this time. I'm again going to call it note, because what else would I call it? X in this case cannot equal either 4 or 2, because if x is 4 or 2, we would zero out one or the other of the denominators. In particular, x cannot equal 4. So where we thought we had x is equal to 4 or negative 1, we don't include the 4. X is simply negative 1. Again, this is something we need to look out for whenever we start out with a variable in a denominator. Now before we move on to our last example, I want to just throw a little bug in your ear. I don't know why people say that. Here we lost the solution x is equal to 4. What if we had also lost the solution x equals negative 1? In other words, what if both of them zeroed out a denominator? If the only solutions that you have are illegal, you don't have a solution. And so in that case, like if we had it so that x could not equal 4 and x could not equal negative 1, but those are our solutions, then we would say no solution, which we could indicate with a circle with a line through it. This also could have potentially happened in the previous example. Here we had, moving back a screen, we ended up with 1 plus 1 equals 2, which we wrote as all real numbers. If we ended up with like 1 plus 1 equals 3, then that being a false statement would have also led us to conclude that there was no solution. Okay, so the things that you knew about false statements leading to no solutions are still true, and now we pick up the added bonus if the only solution that you have is illegal, then you don't have a solution. For our last example, we have 5 over x minus 2 over 2 minus x is equal to 4 over x plus 1. We might be tempted to smash all these denominators together and call it the least common denominator, but it's actually not the least common denominator. The first denominator is x minus 2. The second denominator is 2 minus x. Same numbers, a different order. These are actually opposites of each other, which we could see if we wrote that second denominator, 2 minus x, first in descending order. Then we'd end up with negative x plus 2. If we factor out a negative, we have the negative of the quantity of x minus 2, which is the negative, as we said, of the first denominator. So if I rewrite the entire equation here, I have 5 over x minus 2 minus 2 over the negative of x minus 2 is equal to 4 over x plus 1. So just beware negatives, or beware opposites. Now the negative that exists in the second denominator, negative quantity x minus 2, indicates that that denominator has been multiplied by a negative. So if we unmultiply it by the negative, actually kind of bring it out front, then it will interact with the minus that was in front of that second term. We essentially have negative times negative, which is going to give us plus. In other words, this equation now becomes 5 over x minus 2 plus 2 over x minus 2 is equal to 4 over x plus 1. Now that I have like fractions on the left-hand side, we have common denominators, we can say we've got 7 over x minus 2 is equal to 4 over x plus 1, and now we have that beast that we call a proportion. Fraction equals fraction, which we can solve by cross-multiplying. Cross products of proportions are equal. So we have 7 times the quantity of x plus 1 is equal to 4 times the quantity of x minus 2. Distributing, because we have parentheses, gives us 7x plus 7 is equal to 4x minus 8. Subtracting 4x from both sides gives us 3x. Subtracting 7 from both sides gives us negative 15. So 3x equals negative 15 finally gives me that x is equal to negative 5. Now, we would look back at the original equation to make that little note that we keep making. And what I notice is that x cannot equal 2 or negative 1. Since we came up with x equals negative 5, we're okay on that score.